Hello everyone, I'm Akash Mehra, and in this poster we'll be talking about a comparison of implicit versus explicit style transfer using GANs for continuous path keyboard input modeling. In continuous path, user inputs a word by sliding their finger from one letter to the next. There's a lot more ambiguity in this form of input method, and a robust solution requires a large amount of training corpus, which is expensive and time consuming to collect. So we rely on data synthesis to deploy a robust solution. There are two different methods that we study. First is implicit style transfer. In implicit style transfer, the notion of style remains diffused across the entire reference corpus. The architecture is actually shown in the second panel. Um, a programmatically generated input path X is transformed into a more realistic synthetic path, Q, which is based on a set of user-generated reference paths. Q is also passed to a classifier, which verifies that the generated path is still associated with the intended word. We use a combination of adversarial loss and a classification loss. For classification, we use connectionist temporal classification. In explicit style transfer, each path is encoded into distinct latent space. The architecture is illustrated in the third panel. A style encoder extracts a style embedding Z from P. A content attention module provides a focus context of input text D. Both the style embedding and the attended context are passed as an input to the generator to synthesize the resulting path Q. The GAN-generated path Q is also passed to a classifier to ensure that it indeed is associated with the correct intended text. Let's talk about some testing conditions. We had access to a set called U2, which is a set of user-generated paths collected for a vocabulary of 55,000 English words. And it was used to generate a set G2, which is a 2.2 million GAN-generated paths using implicit style transfer, and another set H2, which is a set of 2.2 million examples that are generated using explicit style transfer. For comparison, we also use the largest set, U5, comprising of 5 million user-generated paths. In addition, with the help of a wide coverage English lexicon, an alternative set H2 star of 2.2 million style disentangled paths was also generated. This time it was designed to cover words both inside and outside of the 55,000 inventory, thus providing training data for words for which no user data is available. Some of the results that we observed are actually shown in the table. For an in-depth analysis, both quantitative and qualitative, of the results, please refer to the section 5 of our paper. Some of the conclusions that we can actually draw from this study is that explicit style transfer does not confer material benefits over implicit style transfer in presence of linguistic resources. The two generative models are complementary in the kind of user-realistic artifacts that they produce. Explicit style transfer allows finer control of local behavior, whereas implicit style transfer renders observed attributes more diffusely across paths. In future work, we would like to investigate the effects of GAN-generated data on low-resource languages and focus mainly on zero and few-shot learning procedures. Thank you for listening to us. Have a wonderful day. And in case you have any questions, please reach out to us.